Transactions will be objects that represent exchanges in our cryptocurrency. They will consist of three primary components. First, an input field which provides information about the sender of the transaction. Second, output fields which detail how much currency the sender is giving to other wallets. And three, a unique ID to identify the transaction object. The primary reason for giving transaction objects unique IDs is that this makes them easier to find in transaction object collections. So let's start with this unique ID. To generate an ID for transactions, we'll use a module called UUID. So let's install npm i uuid-save. So npm i for npm install, and then uuid-save on the command line for the project. UUID stands for Universally Unique Identifier. This UUID module gives us a function which can generate a random string of 32 characters that is partly based on the current time. In order to create unique IDs for objects, we'll use that ID generation function. So let's use this UUID module directly in our chainutil.js file. So make sure you're in chainutil.js. There are multiple versions of the ID generating function of the UUID module, but version 1 fits our use case since it's timestamp based. So right at the top of the file, let's create a UUID capital V1 constant, which is going to be the result of requiring the UUID /v1 module. So now this UUID v1 is a function which generates a unique ID. Now in our chainutil class, we can write a function called ID that returns a call to this UUID v1 function that we just required. So let's make the static ID function, and then this will return a call to UUID v1, which is the function we just imported. Great. With the ability to generate unique IDs now, we can move on to creating the actual transaction class. So let's create the transaction.js file within the wallet directory. So let's make transaction.js within wallet. So that's wallet/transaction.js. We'll start by requiring the chainutil class right at the top, since we'll be using that ID function. So we're going to acquire the chainutil file, which is back one directory above this. So have that double dot over here right before chainutil. And now we can create our transaction class with an empty constructor, which we'll fill up in just a moment. And every constructor object, or rather every transaction object, will have three fields. The first one is an ID, which we'll set right away by calling the static ID function. So let's say this.id equals chainutil.call the static ID function. And the next part is an input field, which we'll set to null for now. And finally, we have the outputs field, which we'll set to an empty array. Great. This covers the skeleton of the transaction class. Now we still have to fill out the input and output fields. Let's start with the output fields. In a transaction, outputs consist of one output, which details how much currency the sender wants to send to an individual. And then a second output specifies how much currency the sender will have after the transaction is complete. To give users the ability to create these outputs, let's create a static method called newTransaction. So that's a static method called newTransaction that is camel cased. So note that newTransaction is one word. The newTransaction function will have three inputs. The first one will be the sender's wallet. We'll want the sender's wallet to look at their balance and the public key of that wallet to create an output that represents how much currency they should have after the transaction. The next parameter will have the address according to who we're actually sending currency to. So let's call this the recipient address. Note that it's just recipient for the parameter. And finally, the last parameter is the amount of currency to send with the transaction. Great. The goal of this function will be to return a new instance of this very transaction class with the proper outputs specified for the sender and the recipient. So to return a transaction instance, well, we need an instance first of all. So let's make a local transaction instance by setting it to a new call to this which refers to the own transaction class. Before we move on from this function though, we need to make sure that users don't attempt to create a transaction that sends an amount that exceeds their current balance. So let's check if the given amount exceeds the balance in the sender's wallet. And if so, we're going to return out of the function and also log a helpful message that is essentially an error. So if the amount is greater than the sender wallet's .balance, let's log an error to the console and we'll say the amount is exceeding the current balance. So amount exceeds balance. Notice the use of a template string with backticks, those diagonal tick marks next to the one key on the keyboard, and then $ curly brace insert the amount that is given to the transaction. And then we don't want to continue with the function if it hits this error case, so we're going to have a return statement which will return and escape out of the function. Within this instance, now we can create the proper outputs for the transaction object. Each output object has an address and an amount field. The first one is the amount and the address for the sender. The amount is the sender's wallet balance subtracted with the amount given to the function. So to add this output, let's look at the transaction's outputs, and then we're going to use the push function, which pushes elements to the end of an array. Now we're going to want to insert two objects, so we can use the ES6 spread operator by creating an array of two objects that will push to this array of outputs, each object individually one at a time. So in this inner array that we're now spreading out with the ... spread operator, we can create the relevant output for the sender. And the amount for that output is the sender wallet's balance, so sender wallet.balance, minus the amount that they're sending away and subtracting from their own balance. And then the address for this output is the sender wallet public key that is contained within the given sender wallet. Great. For the second part of this outputs array, we have the output that actually sends currency to the recipient. So we're going to construct a similar object. This time the amount is the exact same thing as the given amount. So the ES6 destructuring syntax allows us to create a key and value in one at the same time if the actual value name and the key name are the same. And then the address is the given recipient. Great. Finally, this completes the function, so let's return the transaction as a result of the static new transaction function. Excellent. We now have a way to generate a transaction object with a unique ID and the relevant output objects. Finally, let's make sure that this transaction class is shared by setting it to module.exports so that way other files can actually use it. Moving on, let's test this new transaction class we just created and make sure the outputs that we created for the transaction match what we expect them to.